are the University of Tokyo team. So first, let me explain to you the team approach, what we do, what we did actually. So we divide our work in three parts. So the first is the concrete information related to STI policies. For that, we use the keyword searching in the strategies database specifically. And then we made a kind of analysis of the quantitative results focused on the keyword frequency aggregated at the country level. And also we propose to you further development by using extracting paragraphs at document level. And the part two is the relationship between STI policies. For that, we use a topic modeling. Then we obtain a characteristic vector by country in accordance with the topics already modeled. And then we obtain some data from the similarity between countries considering those selected topics. And for that, we also made an analysis related to what topics are more concerned to part one, keywords that are more related to solve and answer the key question of our team, and also about which countries are more focused on those topics in accordance with their characteristic vectors. In addition, and a complementary part is the MOIP and strategics section. For that, we classified the dataset, the strategies dataset, into MOIP, mission-oriented innovation policies, and no MOIP documents. So for that, we use the basic keyword searching, and also we made some topic modeling in each of those groups. So, and then we present to you some kinds of further development proposals to analyze the results by the OECD members. Okay, so let's go to part one. So we obtain 6 indicators or 6 key groups, keywords groups. So the words in each set came from previous literature reviews, our knowledge, our team leader actually advised, and we use some insights from the STIP compass in terms of selecting the words that you can see here. So for example, related to the strategies in the policy documents, we use a strategy, words as a strategy, plan, agenda, policy, program, and so forth. For example, for budget, we use words like budget, fund, grant, investment, and budget allocation, and so forth. With that information, with that algorithm, we then, for each policy document, we compute 2 vectors. The first one is the word count, and the second one is the word frequency. So for example, here, you can see the results of the word count for every policy document of Australia. So there are the 6 groups, the 6 keywords groups, and the word count of strategies and goals and so forth. So this is one example of the resulting information, the resulting data. This is the complete vector matrix of the vectors of keywords count aggregated at the country level. In this sense, we mean that aggregation is corresponds to the mean of the keyword count of all policy documents by a country. So for example, coming back to Australia case, for timeline related information from the data set, we obtain a mean of a half document, a half word related to timeline that appears in all of the documents, policy documents from Australia. And this other one is reflects the results related to frequency aggregated at the country level, the word frequency aggregated at the country level. In both tables, it is possible to see the countries that present the higher values, the higher count of words and the higher frequency of words in blue, and the other has less values. It means that, for example, in this one, Australia focused less in timeline topics, in timeline related policy information than, for example, Belgium. Okay, So the second part of this, the second section of this is the analysis. For that, we propose you to extract the paragraphs containing each keyword. So this is a potential use of the keyword search that we already done, using GenSims to summarize paragraphs at a policy document level. So we suggest you make something like this. So there are our original policy document. There are different paragraphs that contain, for example, the keyword goal, that is related to implementation of the policies. So there are different paragraphs containing goal. So using GenSim, it is possible to summarize all the goal-related paragraphs in only one document, from only one document, and then make the same process to other documents from the same country and so forth. So let me explain a little more about that. So in this sense, we propose a keyword-based searching to extract the paragraphs related to strategic goals, timelines, budgetary commitments, and all the other keywords. So using that, we target a sentence. With that sentence, we add sentence before and sentences after. And for example, coming back to the case of the Australia, because the words related to timeline set appears 2 times here in the first policy document, so there will be 2 extracted paragraphs for timeline. So they come by the algorithm. It is possible to summarize in only 1 paragraph by using GenSim. Therefore, in total, for the case of Australia, there will be 7 summarized paragraphs related to timeline for all policy documents of Australia. So the same process would be done for other keywords and countries. So it means that an additional human process of analysis of the resulting summarized paragraphs is needed to go deeply in what information is provided in strategies about policy implementation. There are one example that comes from an US policy document. So this is just 1 paragraph for 1 keyword, but by using the GenSim, we can summarize all the paragraphs, all the results in only this paragraph for that document. So it will be useful to reduce the human time that will be needed to analyze those documents. Okay, going to the part 2. So we made the topic modeling results, something similar to the previous theme. So we use for select how many topics are more suitable to represent the data set. We use the coherence score that specifically there are the simple explanation of how it works. So we finally found that 14 is the amount of topics that better represents the data sets. So with that, we made this word cloud that provide insights of how to summarize or make a kind of set of information related to the same topic. For example, our topic 0, the first topic we found, we call green technology, and there are a lot of words that are related to green technology in all the documents from the data sets. There are other examples. We made 14, and considering the elements obtained, we select which are more related to policy implementation because it's our question. So from the 14 topics, we only select 7 as our focus: public finance, assessment, public support, education and training, management, national innovation system, and investment. With that, we also create a characteristic vector based on the topic modeling results. This is the formula, but I don't want to go deeply in this because the time. So let me just show you the results. So this is a representation of all the vectors data for all the 24 countries included in the data set. So you can see here in orange the top 1 country for each of the 14 topics we modeled, as well as the second and third places. So for example, Chile presents a big value for the topic 5, that is sustainability, but has no value for example, the topic 6 that is assessment. So it is very useful to make a more deep analysis from policymakers and analyzers in the OECD. We made here some analysis, some conclusions from the matrix that I already explained, but let's go a little more deep and ahead. So the third part is the similarity between countries. So with the 7 selected topics, we use the cosine similarity matrix derived from the vector representation, and we found a resulting 24 times 24 matrix. So this is useful to compare how much, for example, to make an analytical work to what will be the relation between one country and another country in terms of the 7 selected topics related to implementation of policies. In this case, for example, United Kingdom is very close, is closer to United States in the implementation topics than, for example, United Kingdom with Finland, for example. So this is a kind of analysis. And the last one is the mission-oriented policies. So for that, we separate the documents into groups, MOIP and no-MOIP, using these words, these keywords. Initially, we used these ones, and we found that only 18% can be classified as MOIP related. For that, with the advice of our team leader, we add other keywords, and finally we obtain that around a half of the document can have some relation to mission-oriented policy. For that, with that, we made also a MOIP topic modeling inside each group. I mean the group of MOIP-related documents and the group of no-MOIP-related documents, to make a kind of comparison between what kind of topics appeared. So there are the 10 topics that we found, and for further development, we suggest you to add more stop words to refine the topic modeling process, make comparison between topics of MOIP and no-MOIP, also make some algorithms to obtain the relations between MOIP principles and the topics we found, make the cosine similarity between characteristics vectors of both groups, and rerun the part 1 that we made for each group. We also have some additional section, but anyway, you can consult it specifically on the slides that are already published in the GitHub folder, that are specifically, we made a work combining the STI policy and other sources, such as the GDP per capita, obtaining, for example, a significant negative effect of GDP per capita on the spatial relationship with the number of STI policy documents in the data set. And also we made an additional work combining the STI policy and the COVID-19 category that we have within the data set. Okay, this is it. This is all for us, and thank you very much.
Thank you very much, Cindy. That's really very rich. Philippe, are you there? If you could make a quick reaction, because we are a bit late on the schedule.
So very rapidly, we had a meeting a few hours ago, so I won't go through everything we discussed. No, just to say that, again, to thank the team very, very much, because this is indeed a lot of work, and that open up new possibilities, and we have to get our head around this new type of analysis. So that was really wonderful. Only 2 things that we discussed together to make that type of work function between the teams of the technicians and us more on the policy making analysis and policy making side. It's really about how to find the right way to communicate to each other and find so that we can understand that, for instance, the slides as we see them are very much focused on the technicity that is behind, because that was kind of the hackathon. So, but at the same time, if we don't, sometimes we miss, us as policy analyst or policy maker, we would miss some specific elements of understanding that really determine the whole thing, like the two of the metrics are coherence and relatedness, and nowhere in the slide it says what is considered coherence and relatedness. So these are kind of things that sometimes a bit more qualitative explanations would really help. So that was really interesting. And the other lessons is that there need to be some indeed interactions along the way in this cooperation. Unfortunately, I was not really available last week, so that was complicated, and I could intervene only this morning. So that was far too late because everything has been done. But that really shows that it can work, provided we can interact, and there is really a dedicated effort to translate these technical things into something that can be taken up by us and understood. Otherwise, it's even hard for us to assess, because there are metrics, there are graphs, and if we don't understand what is considered coherence and how it's related, what is it coherence within a document, within a sentence, within a paragraph, within a set of documents, etc., etc. All these type of questions really completely change our understanding of the results. But again, thank you very much. And for the third part 3 on MOIPs, as I mentioned to the team, we've tried at OECD to isolate within STIP Compass, for instance, MOIP initiatives using a dedicated algorithm and keywords and etc. And that was not very conclusive, which shows not that the technique is not good, but that the concept is pretty fuzzy, maybe. So again, that is a very we appreciate the effort of the team to even provide more than what we expected, just on the fact that they knew that we were working on a mission, so they try to provide even more. So that's really appreciated, and we are very grateful. Thank you very much.